Hi students, today we are going to discuss questions on competitives NEET, JEE, CET, likewise based on metallurgy. It is very important topic and easy topic to remember and easily you can gain the marks. Question number 1. Fourth flotation process used for the concentration of the ore of option A iron, option B aluminum, option C chromium, option D copper. I repeat the question. Fourth flotation process used for the concentration of the ore of options are given: iron, aluminum, chromium and copper. We learned that fourth flotation is useful for sulfide ores. What type of ores are concentrated? Sulfide ores are subjected to concentrate by fourth flotation method. And here we have to cross check the ores. You go for iron. Iron is in the form of Fe2O3, Fe3O4, FeCO3 and so on. This is we are calling hematite. This is we are calling magnetite. This is we are calling calcite. What we are calling? So these all are oxide ores. So oxide ores not possible. But we have iron sulfide. But iron sulfide is not ore of iron. Iron sulfide is not the ore. This is we are calling fool's gold also. Remember, iron sulfide is called as fool's gold. Though it is in the form of sulfide, it is not used as ore. The ore you have to remember that ore of iron sulfide is not the ore. So option A is wrong. Option B, aluminum. Aluminum having the minerals we have Al2O3 2H2O, Al2O3 like that. And this is we are calling bauxite. And this is we are calling corundum. This is we are calling corundum. So these two are not ores. That's why aluminum is not the ore of sulfide to concentrate by fourth flotation method. And you go for chromium. Chromium ore we have. Chromium ore. What is the chromium ore? Recall the chromium ore. Chromium is in the form of chromite. Chromium is in the form of chromite. Chromite is oxide form. That is FeCr2O4. FeCr2O4. This is we are calling chromite. So it is also not sulfide. So this is also wrong. And remaining option is copper. Copper, we have the words Cu2S, copper glass. Copper glass. So copper glass is the ore of copper. Copper glass is the ore of copper. That's why answer is Cu. So generally we are learning that sulfide ores are concentrated by fruit flotation method. That is their question. Like these questions also they will ask. Fruit flotation process used for the concentration of the ore. Iron not possible, all are oxides, but we have FeS, but it is not the ore. It is not the ore. And another name we are calling fool's gold. And aluminum all we have oxides, chromium also oxides, but copper we have copper sulfide, and that is we are calling as copper glass. So Cu is the answer. So this is the method how to remember the concepts. So question number 2. Question number 2 we have here. Copper is extracted from from sulfide ore. Now only we discuss sulfide ore by using the following method. Option A, reducing with carbon. Option B, reducing with carbon monoxide. Option C, auto reduction. Option D, none of these. And this is the question given. Copper is extracted from sulfide ore, we know already, by using the following method. Reducing with carbon monoxide, auto reduction nothing but no external reducing agent going to be used. Look here, we learned copper sulfide is subjected to heat and you are getting copper oxide plus sulfur dioxide. This copper oxide react with this copper sulfide again, giving copper plus sulfur dioxide. So here we didn't use any reducing agent. That's why copper extracted from sulfide ore by the following methods means auto reduction. Remember, copper metal, that is crude copper metal, we are getting by auto reduction method. Auto reduction means no external reducing agent going to be used. So this is another important question for competitive purpose. Next, we have few more questions. Which of the following metal is not found? Which of the following metal is not found? In native state. Which of the following metal is not found in native state? Go for sodium, aluminum, gold, option C silver, option D copper. These are the options given. Which of the following metal is not found in native state? Sodium, gold, silver, copper. So we learned that elements exist in two forms, native form and compound form. Native form means which are low reactive, and compound form means which are reactive. Low reactive means these not affected by oxygen, carbon dioxide or non-metals, but these are ready to react with oxygen or carbon dioxide or with non-metals. So this is low reactivity. So to remember native and compound form, we have metal reactive series. Metal reactive series. This you have to remember. Then we can make the answer. Here I am giving most reactive metal sodium, potassium, sodium. Then we have these two are one A group, calcium, magnesium. In first group, in second group we have aluminium, zinc, iron, tin, lead, hydrogen, and down we have copper, silver, gold. Remember that the metals which are above the hydrogen are more reactive. More reactive means they are not in native form, they are in compound form. Metals which are in series down that is below the hydrogen, those are copper, silver, gold, are low reactive. Low reactive means they can't affected by these elements, and these are in native form. These are in native form. So below the hydrogen are in native form means free form. Above the hydrogen are in compound form. This is the trick to remember which are native. These all are in native. And this is in compound form. Now you go for native form. The question asked, which of the following metal is not found in native? Copper native, low reactive, silver native, low reactive, gold native, low reactive, sodium more reactive, compound form. That's why our answer is sodium. Sodium is not existing in native form. This is the metal reactive series you have to remember. That is question number 3. Likewise, we will go for another. Question number 4. The magnetic oxide. Of iron ore is. The magnetic oxide of iron ore is, and this is FeCl3 iron carbonate, and this is Fe2O3, and this is Fe3O4, and this is FeSO4. These are the options given. For us, which is called as magnetic oxide. Remember, here we have Fe3O4. Fe3O4, well known as magnetic oxide. This is also oxide only. Sorry, this is oxide, this is carbonate, this is oxide only. This is called as magnetic oxide. Why? Because it having ferrimagnetic nature. Fe3O4 is called as magnetic oxide because it has ferrimagnetic nature. That's why answer is Fe3O4. So direct answer you can remember easily. Fe3O4 is well known as magnetic oxide because it is having ferrimagnetic substance. So more attractive. Next, question number 5. Second most abundant metal in earth crust is second most abundant metal in earth crust is iron, aluminum, sodium, calcium. So which are the following metal showing second most abundant metal? So abundance we have to remember what percentage they are there. So as we discussed that most abundant element is oxygen. This is 49.5%. Second abundant element is silicon, 25.7%. And third element is aluminum, 8.31%. Next iron is 4.7%. Next calcium we have 3.4%. This is the top 5 elements. So most abundant element is oxygen. Second most abundant element is silicon. Third most abundant element is aluminum. Fourth iron. But they are asking second most abundant metal. Second most abundant metal. Among metal, aluminum is top, means first, and iron is second. So answer is A. Iron is second most abundant element and aluminum is most abundant metal. Oxygen is most abundant element. So when you are reading the question, you should be very careful whether they ask element or metal. Element is oxygen, and if they ask most abundant metal, then aluminum you have to take. This is how abundance going to be remembered. Next, question number 6. We have method used for the concentration of tin stone is means they are asking how tin stone is going to be concentrated. Option A, hand picking. Option B, froth flotation. Option C, magnetic separation. And option D, we have here none. Option B, we have here none. Which method we are using to separate, that is concentrate tin stone? First we have to know that what is meant by tin stone. Tin stone. Tin stone nothing but SnO2. Tin oxide. Tin oxide. This is we are calling tin stone. And another name, k-cet. Remember, k-cet or tin stone. And it is having the magnetic property. Magnetic property. Tin stone showing the magnetic property. Where magnetic property is generally we are using as magnetic separation. Fourth flotation is for sulfide ore. It is not sulfide. Hand picking is for only stones and sand particles we are picking out by hand. So magnetic separation, magnetic property, the metal ore which is having magnetic metals and non-magnetic impurities, such we are calling, we are concentrating by magnetic separation method. Fourth flotation is not for magnetic. Why? Because what the principal property in fourth flotation? Difference in wetting property. Next question we have here. Galena is the ore of. Galena is the ore of. Option A, lead. Option B, mercury. Option C, silver. Option D, tin. Galena is the ore of which are the following metal? If you know the Galena formula, then easy to remember. You know, lead oxide, that is lead glands, we are calling Galena. Mercuric oxide we are calling, mercuric sulfide we are calling cinnabar. Cinnabar. Silver sulfide we are calling argentite. Argentite. And tin stone here we have another oxide form. So lead glands is another common name, Galena. Mercuric sulfide, cinnabar. Ag2S, argentite. SnO2, tin stone. Now the Galena is lead. So lead ore is called as Galena. This you have to remember a little bit. Not only ore name but also common names also you have to remember. Next, another question we have here. Which of the following metal? Which of the following metal? Which of the following metal is reduced by? Is reduced by water gas. Water gas. Options are Fe2O3, nickel oxide, zinc oxide, iron carbonate. Which of the following metal is reduced by water gas? Generally, this is metal oxide. Metal oxide. Which of the following metal oxide is reduced by water gas? water gas. Which of the following metal oxide is reduced by water gas? Remember that nickel oxide is reduced by water gas. Water gas formula you know very well, COH2. In this, carbon monoxide act as reducing agent, hydrogen also act as reducing agent. When nickel oxide react with carbon monoxide and hydrogen mixture, that is water gas, you are getting nickel, carbon monoxide reducing agent get oxidized to carbon dioxide, hydrogen is reducing agent get oxidized to water. This is the reaction. Remember, with water gas, generally we have a metal oxide to reduce, that is nickel oxide only. Only nickel oxide we have in our syllabus. And this is how to remember. Now, nickel oxide is the answer we have here. Nickel oxide. Next, another question we have here. Flux is used during extraction of iron, from hematite, in blast furnace, SiO2, CaCO3, CO. This is the question given. Which flux you are using in blast furnace during extraction of iron? Look here, flux. We have two types of flux: acidic fluxes and basic fluxes. Acidic fluxes we have like SiO2, P2O5. Remember this for PUC also important. SiO2 acidic and P2O5 is acidic, and borax also acidic flux. And basic we have CaCO3, MgCO3 and like Fe2O3, this we have. So these three are acidic fluxes, these three are basic fluxes. Three only, not so many we have. Minimum you have to remember this. These two type of fluxes we are using metallurgy. But blast furnace, what we are using for iron extraction means selection of flux depending on type of impurities. If impurities are acidic in nature, we have to use basic flux. If impurities are basic in nature, we have to use acidic flux. This is the method you have to remember. Here, where we are extracting iron, the impurities we are getting SiO2. SiO2 is acidic in nature. That's why we have to use a basic flux, any basic flux. Here I have given the calcium carbonate, magnesium carbonate, and generally in blast furnace we are using CaO as basic flux. It is from calcium carbonate. We are adding calcium carbonate, from that we are getting CaO. When CaO react with SiO2, it is giving as calcium silicate. Calcium silicate. Flux plus impurities, you are getting slag. What you are getting? So flux plus impurities giving rise to slag. So type of impurity depends. That's why answer is CaCO3. That is basic flux. Next, another question we have here to discuss, that is purest form of iron is. What the question they are asking? Purest form of iron is. Which iron is the purest form? Option A, pig iron. Option B, cast iron. Option C, sponge iron. Option D, wrought iron. So, students getting problem to spell this wrought iron. WROUGHT. Wrought iron. These four types of irons we have: pig iron, cast iron, sponge iron, wrought iron. Which is the purest form? Purest form. This is one theory question direct. We have here purest form of iron is wrought iron. Wrought iron. It having malleability nature, ductility nature also. So this is purest form. Means impurities also present, but less impurities are present when compared pig iron, cast iron, sponge iron. In this all we have impurities nearly 1 to 2%. 1 to 2%. But when compare other, less impurities are present. That's why we are calling purest form. Purest form. Next we have another question, that is which method of purification used for the following purification method we have to use. The given equation, titanium plus 2I2 giving rise to 523 Kelvin temperature. Titanium tetraiodide, it is nearly 1700 Kelvin heated, and they got titanium and iodine. To this method, to this reaction, which purification method we are going to be use? Options are given: zone refining. Option B, cupellation. Option C, Van Arken method or process. Option D, Mons process. Titanium with iodine. This is titanium we have impure, and this we have titanium pure. Titanium and treated with iodine, getting titanium subjected to heat at high temperature, we got pure titanium. Which method? Remember, we have titanium and zirconium are refined by vapor, that is vapor phase purification method. Vapor phase purification method. Refining. That is, we have here vapor phase refining, Van Arken process. What here we are doing? We are converting impure metal to volatile compound. Clear? Titanium tetraiodide we got. This is volatile. And further it is heated at 1700 and you are getting pure titanium. So only titanium and zirconium has to purify by Van Arken method. So answer is Van Arken process or method. And this is one more question here. Next, we will go for another important question. Which is given. And here one matching question they given few. Here A as bauxite, they given corundum, next cryolite, and here feldspar, and here B given KAL Si3OH and Na3 AlF6 Al2O3 2H2O. Match the following. They given. See here, all are minerals of aluminum. Bauxite, corundum, cryolite. These all we have here. Feldspar, this. You know very well. And here I am making 1, 2, 3, 4, A, B, C, D. One is bauxite formula Al2O3 2H2O. Corundum nothing but Al2O3 C. And 3 cryolite formula Na3AlF6 and 4. This is feldspar we are using in talcum powder also, that is A. So bauxite here, corundum here, cryolite, this is, and this is feldspar. This is one matching we have. All of you remember the minerals of aluminum, iron, zinc, like that. Then easy to match. Next, another question we have here, that is formation of slag at option A 600 to 800 degree temperature. Option B, 800 to 1000 degrees Celsius. Option C, 170 to 800 degrees Celsius. Next, 200 to 600 degrees Celsius. In iron extraction, that is in blast furnace, formation of slag at. This is one theoretical question. You have to remember 800 to 1000 degrees Celsius between slag is going to be formed. This is we are calling central zone. Remember, slag zone is called as central zone. Another name for slag zone is central zone. Here slag is going to be formed. What happened here means heat will be absorption. Means heat absorbed. Heat absorption will be takes place. Central zone. Then here what we are getting means slag is going to be formed. That is CaO, flux, react with impurities. That is I told already. This is slag, calcium sulfate. This is impurities and this is flux. This will be happens in central zone or slag zone. Slag zone. So this is one of the important question we have here. Clear? Next question we have as which of the following is blister copper? Blister copper. The question is given like this. Which of the following is blister copper? That is option A, pure copper. Option B, copper ore. Option C, copper alloy. Option D, impure copper. And this is the question given. Which of the following is blister copper? Pure copper, nothing but pure form of copper. Copper ore, that is we are calling copper sulfide. Copper alloy, copper plus zinc. And now here we have impure copper. Impure copper is called as blister copper. Remember, impure copper is called as blister copper. Means this is blister copper. Impure form means 97 to 98% only pure. Such copper we are calling impure copper. Impure copper nothing but blister copper. So another name for impure copper is blister copper. So like these questions, and based on Yellington diagram also they are asking the questions, that also you have to concentrate. Thank you.